Okay, this is problem number 9 on the chapter 1 and 3 review. We're going to answer this question by treating it like how you'd calculate your final grade for the semester, including final exams. The way that we're going to do that is we're going to use this formula. Your final semester grade is calculated using 3 components. Your quarter 1 grade, which we're going to multiply by 40%, otherwise known as 0.4. We're going to add to that your quarter 2 grade, which we're going to multiply by 40% or 0.4. And finally, your final exam grade, which we're going to multiply by 20% or 0.2. If you take all of these components and you add them together, you get your semester grade for semester 1, let's say. So let's say that you're coming into the final exam and you want to make sure that you have a total of 93% for this semester. Let's say that in quarter 1 you had a 95%. Let's say that in quarter 2 you didn't do quite as well and you had an 89%. What we want to calculate is what you need to earn on the final exam to bring your grade to a 93%. So the way we do that is we're going to take whatever you got for quarter 1, we're going to multiply that by 0.4. We're going to take whatever you got for quarter 2 and multiply that by 0.4, and we're going to take whatever you get on the final exam, we're going to multiply that by 0.2. That means we want all these things to add up to 93%, which is of course the minimum grade to get an A for the semester. So let's do this and we'll solve for x. Okay? Alright, so coming into this, we'll say we're going to take your quarter 1 grade. You're going to say 95% times 0.4. You're going to add to that 89% times 0.4. You can add to that x, which you don't know, times 20% or 0.2, and all that needs to add up to 93. So to make things a little easier, I'm going to crank all these out and I'll show you how this works. We're going to say 95%, which was your first quarter grade. Let's clear this. 95%, we're going to multiply that by 0.4. This is 38. Let's take your second quarter grade. We're going to say 89%, we're going to multiply that by 0.4. This is 35.6 plus whatever x is times 0.2 equals 93. Well, let's solve for x by subtracting both sides, 38 and 35.6. So, to get this, we're going to say 93 minus 38 minus 35.6. Whatever this comes out to be, this is going to be equal to x times 0.2. So let's take our calculator and we'll say 93 minus 38 minus 35.6. This is 19.4. Well, to get x, we're going to divide both sides by 0.2. When we do this, x is going to equal your final exam grade that's necessary to bring your average all the way to an A, or 93%. So all we have to do to solve for x, we're going to take 19.4 and divide that by 0.2. This 97 is what you need to earn on the final exam to maintain your A. Okay? So now that we know how to do that, let's take a look at this problem. And let me take a moment here to erase everything. Okay? So we're going to do the exact same thing for boron. Here's what we know. We know that on average, boron has an average atomic mass of 10.81 atomic mass units. Most of the boron has an atomic mass of 11. You can, just round this to a whole number. What we're going to say is, okay, we know that 80.2% of the boron that occurs naturally has an atomic mass of 11. So we're going to treat this just like we treated calculating your semester grade, where the average semester grade is 10.81 atomic mass units. And what we want to do is we want to calculate how much of the boron in naturally occurring boron is an atomic mass of 11, which we know is 80.2%, and the remainder of boron, which is going to be 19.8%, is going to have a different atomic mass. So here's how we're going to set this up. We know, that the total average atomic mass of boron is 10.81. Let's not worry about the units. We get this by taking boron, which has an atomic mass of 11, and that's 80.2%. We're going to get that into a decimal because it's a lot easier. 0.802. The remainder, 19%, or 0.198, is something that we don't know. When we add these together, we should get 10.81. So what we're going to do is we're going to solve for x. We're going to do it just like we did solving for your semester grade. We're going to say that the sum of 11 times 0.802 plus this value x that we don't know multiplied by 0.198 is equal to 10.81. All we have to do is solve for x. So I'm going to do it just like I did by cranking these out. And here's what we get. Let's take our calculator and clear this. We're going to say 11 times 0.802. This is 8.822. So 8.8, let me make that look a little bit more like an 8. 8.822 plus x times 0.198 equals 10.81. Well, let's get rid of the 8.82 by subtracting that from both sides. And now what we have is this. I'll say 10.81. We're going to subtract 8.822 and we get 1.988. So what we now have is x times 0.198 equals, hang on, I want to make sure I got the value right, 1.988. 1.988. How are we going to solve for x? All we're going to do is divide both sides by 0.198, and this is going to give us the other possible value of boron that occurs in nature that makes the average 10.81. So, solving for x. Should be pretty obvious by now. 0.1988, we're going to divide that by 0.198. This is 10.04, just call it 10. That means the other possible isotope of boron has an atomic mass of 10. And that's all you do. If nothing I just said makes any sense to you, here's a good example for calculating atomic mass. And it says it's dependent both upon the mass and the relative abundance of each element's isotopes. So here it says copper 63 is 69.15% of the naturally occurring copper. It says it's got an atomic mass of 62.9, which rounds to 63. The rest of it is copper 65, which has an atomic mass of round that to 65. That's 31% of it. You add those together, you get the average atomic mass, which we see to be here, 63.55. All right, take that for a spin. Be careful because that's going to be on the Chapter 3 test. Bye.